Hello everyone. In previous class we studied about the Fourier series definition and Fourier constant, that is the value of a naught, a n, b n. Okay. Now today class we'll study to solve the Fourier series, obtain the Fourier series for a function of a periodic function in one of the periodic functions. Okay. For that we need some standard formulas. Here I have to discuss some standard formula. After we will solve some problems. Okay. See here, that is first problem in standard formula is generalized rule for integration by parts. Okay. The first one, integration uv into dx. You know that integration by parts in PUC level, that is the integration of uv is what? U as it is, integration of v minus integration of du integration of v. So that is the formula you studied in PUC level. Now it can be generalized for Fourier series. It can be defined integration of uv into dx is equal to uv1 uv dash minus u1 v double dash plus u2 v triple dash minus u3 v 4 dash, so on. Here u1, u2, u3 are the successive derivatives of u, and v dash, v double dash, v triple dash, v4 dash, they are the successive integration of v. Okay, that means the formula is integration of uv in dx must ensure the sign are plus or minus, not a plus 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 minus minus minus. It's in the form of plus or minus, alternative plus minus plus minus. Okay, the formula is first the u term as it is, v can be integration minus u. This can be first derivative is u1. Okay, we get a first derivative, and v it can once again integrate, we get a v double dash plus u1 once again differentiate, we get a u2, v double dash integrate, we get a v3. Next u2 can be differentiation, we get a u3, v triple dash can be integrate, we get a v raised to power 4. So on up until we have to get a zero term or the terms are vanish. Okay, I will explain in example. So this is the one of the standard formula. It's a very important formula to solve the Fourier series problems. Okay, let's see some integration formulas. Integration e to the power ax sin bx plus d into dx is equal to, what is the integration of e to the power ax into sin bx is a e to the power ax divided by a square plus b square into a sin bx minus b cos bx. Okay, then what is the integration of e to the power ax cos bx into dx? That is the e to the power ax divided by a square plus b square into a cos bx plus b sin bx. Okay, so this is the formulas. Here for a sine, it is a, here coefficient e to the power x divided by a square plus b square is both are common. For that multiplication here, a sin bx minus b cos bx. For cos, a cos bx plus b sin bx. Then how to remember? I will say some tricks here. These coefficients are both are same. See, for a sine, the first term a is same. For a sine, sin bx. For a sine, it's a minus, and ab. First is sine, that's first is sine, next is cos. Here cos is there, for cos first, next sine. The sign are different. For a cos, this is a plus. For a sine, this is a minus. So this is the standard formulas. Okay. Next, sin n pi, that is equal to 0. That means sin n pi, any integration we have to put in here. N is what? Integration. Put n equal to 1, n equal to 2, n equal to 3, n equal to 4, anything. Sin 2 pi value 0. Sin 4 pi value 0. Sin 3 pi value 0. Any integer you have to multiply here, get a 0 value. Okay, for cos n pi, see here, for cos n pi value, it's the minus 1 raised to n. Okay, minus 1 raised to n. This is standard formulas. Okay, if n is positive, we get a, if n is even integer, we get a 1. If n is odd integer, we get a minus 1. For example, cos 2 pi, here integer is 2, minus 1 raised to 2, minus 1 raised to 2, and 2 is a even, we get a 1. If cos 3 pi, we get a minus 1 raised to 3, we get a minus 1. So these are some standard formulas to be useful in Fourier series problem. Let's see some Fourier series problem. See here, it's a very important example. They will ask for 5 marks. Okay. Obtain the Fourier series of a function f of x equal to x square in interval minus, where x is lies between minus pi to pi, and hence deduce that 1 minus 1 by 2 square plus 1 divided by 3 square minus 1 by 4 cube, so on up to pi square divided by 12. So here first question is, they will ask two questions. One, for a function f of x equal to x square, find out the Fourier series. Another one, that series can be reduced into in the form of this form, that's 1 minus 1 by 2 square plus 1 divided by 3 square minus 1 divided by 4 square, so on up to pi square divided by 12. Okay. If they are asking only Fourier series, you have to find out only Fourier series. If reduce this type of series, then I will explain here. First, you have to find out the Fourier series for a function, periodic function f of x equal to x square with interval minus pi to pi. Okay, let's see the Fourier series of a function having a period 2 pi, because minus pi to pi, it means it's a 2 pi. Okay, the formula is what? F of x is equal to a naught divided by 2 plus summation a n cos n x, where n is running from 1 to infinity, plus summation b n sin n x, where n is running from 1 to infinity. So this is our definition of a Fourier series, standard. Okay, then what is the a naught, a n, b n value? We know that the formula Fourier constant a naught value is what? For a time period 2 pi, is a naught is equal to 1 divided by pi integration minus pi to pi f of x into dx. Okay. Next, 1 divided by pi as it is, integration minus pi to pi as it is. What is given? F of x, it's a x square, that's why I am putting x square into dx. Okay, then 1 divided by pi constant as it is. Integration of x square is what? X cube by 3 with the interval minus pi to pi. 1 by pi as it is, put upper limit minus lower limit. Put x equal to pi, we get a pi cube by 3 minus. Next, minus pi, we get a minus of minus, we get a plus pi cube by 3. Okay, solve this, we get a pi cube by 3 plus pi cube by 3, 2 pi cube by 3 divided by pi. Okay, 1 pi get cancelled, we get a naught value is what? 2 pi square divided by 3. We get one of the Fourier constant, that is the a naught, 2 pi square divided by 3. Let's see next one, that is the a n. Okay, first we have to find out a naught, a n, b n value. That value put in this equation, we get the Fourier series of a given function. Okay, let's see a n value. We know the standard formula 1 divided by pi integration. Already I will explain. Okay, I explained in previous class of the Fourier constant. Okay, a n is what? 1 divided by pi integration minus pi to pi f of x cos n x into dx. Okay, then what is? Put the f of x value 1 by pi integration minus pi to pi x square cos n x into dx. We know that here for a you have a UV rule. Okay, generalized UV rule. Okay, what is the UV rule? Integration UV as it is. Then how to recognize which is u, which is v? See here, if you x square integrate, it can be increasing, x cube by 3, x raised to 4 by 4. Okay, that's why I am taking x square as a, it's a easy way. If you differentiate x square, 2x, 2, next the differentiation is 0. We get the, stop the series or vanish the terms. That's why I am taking x square as a u, cos nx as a v. It's a very, it's important, see here, which is you have to take a u, which is have taking v. If you take this one as a u, we get only cos, sin, cos, sin, cos, sin, because cos nx is a minus n sin x. Okay, then once again sin is a cos, it's not a ending the any value. Okay, that's why I'm taking which is term is ending easily. First that term is taken as u and then one is a v. I am taking here u as x square, v as a cos x, applying the generalized rule. Let's see what you get here. See here, a n is equal to 1 by pi integration minus pi to pi x square cos n x into dx. I am taking this is u, this is v. Okay, 1 by pi as it is. Okay, x square as it is, u as it is. First integration cos nx is sin nx by n. Next alternate plus or minus, that's why I am taking minus. Next x square is differentiation is 1, 2x. Okay, next Sin nx is what? Minus cos nx by n. Already one n is there, that's why I'm taking as n square. Okay, next term is plus. 2x differentiation is what? 2. Next, this integration. See here, minus 1 divided by n square is a constant. Cos nx is what? Sin nx by n. That's why already n square is there. And the integration we get a n cube. Here minus sign is there. I am taking that's why minus sin nx divided by n cube. Okay. I will explain once again. This is u. This is v. Okay. This is an easy way to vanish the terms. That's why this term I am taking the u differentiation. This is for integration. Okay. X square as it is, cos nx is what? Sin nx by n minus x square differentiation is what? 2x. Sin nx by n integration is what? Already 1 by n is there, constant taking outside. Sin nx is what? Minus cos nx by n. Then we get a minus cos nx n square. Okay. Next, plus 2x differentiation is what? 2. Next, minus 1 by n square as it is. We get a cos nx integration is what? Sin nx by n. That's why it is n cube minus sin nx divided by n cube. Okay. Then, applying the limit, upper limit pi minus pi. Put that value. Okay. 1 by pi. Okay. X square. This can taken in outside. N sin nx. It's not a power. It's a multiplier. Sin nx with a limit minus pi to pi plus minus plus 2x by constant taking outside 2x by n square cos nx. Okay. Next, plus minus 2 divided by n cube sin nx, applying the each term to the limit, upper limit and lower limit. Next, solve this. 1 by pi. Okay. Put x equal to pi square by n sin n pi, upper limit minus. Next, x square minus pi square is pi square simply divided by n. Next, sin n pi. We get a sin n pi value. Minus. Okay. Next, 2x by n square cos nx. Apply 2x equal to pi. We get a 2 pi divided by n square cos n pi minus x equal to minus pi. That's why it's a minus. We get a minus plus 2 pi divided by n square cos n pi. Okay. Next, minus 2 by n cube as it is. Put x equal to pi, x equal to minus pi. That is sin n pi minus 2 by n cube sin n pi. Okay. You know very well what is the sin n pi value. It's a 0. That's why the term is 0. We know that sin pi value is 0. This term is 0. And cos n pi value is what? Minus 1 raised to n. That's why 2 pi divided by n square minus 1 raised to n cos pi plus 2 pi by n square minus 1 raised to n. This is 0. This is 0 because sin n pi value is a 0. Okay. Remaining term is what? Remaining is what? That we get a an is equal to minus 1 raised to n minus 1 raised to 2 times. We get addition. That's why we get a 2 minus 1 raised to n. 2 into 2 we get a 4 minus 1 raised to n divided by n square. This is the n value. Now find out the bn value. What is the bn? Bn is equal to 1 divided by pi integration minus applying the generalized integration part. U as it is, sin nx is minus 1 by pi integration. This is x square minus cos nx by n minus x square is 2x differentiation. Next, minus cos nx divided by n minus 1 by n constant cos nx integration is minus sin nx by n square. Next, plus 2 into this integration minus 1 by n square is as it is. Then cos nx is sin nx integration is get a cos nx by n cube. Cos nx by n square. They already n square is there, n cube. We get a integration. Then upper limit minus lower limit. Okay. Then solve this applying each term to the upper limit minus lower limit. What you get? We get a 1 by pi. I'm taking here. Put x equal to pi. We get a pi square divided by n cos n pi minus of minus plus pi square divided by n cos n pi plus 2 by pi n square sin n pi minus 2 pi by n square sin n pi plus applying the upper limit 2 divided by n cube cos n pi minus 2 divided by n cube cos n pi. Okay, see here, minus pi square by n plus pi square by n cos n pi, that's why both are cancelled. Okay, next 2 by pi n square sin n pi value is what? 0, that's why it's a 0. This is 0. Here 2 by n cube cos n pi minus 2 by n cube cos pi plus minus, that's both are cancelled. The whole term is 0, that's why we get a Bn is 0. Therefore, then what we get the series? F of x is equal to a naught divided by 2 summation an cos nx dx, sorry, an cos nx plus summation bn sin nx, where n is from 1 to n. Bn is 0, that's why I am neglecting this term. The remaining a naught value is what? We get a 2 pi square by 3, we get a 3 into 2, we get a 2 pi square by 6 plus summation an value is what? 4 minus 1 raised to n by n square cos nx. So this is the series. Here 2 1 the 2 3 we get a f of x is what? Given x square. Therefore x square is equal to what? Pi square divided by 3 plus summation 4 into minus 1 raised to n divided by n square, where n is from 1 to infinity cos nx. So this is the Fourier series. Okay, next what they asking? They asking deduce the series in the form of 1 by 2. That's why I'm taking here. See here, I'm putting x equal, for this series putting as a x equal to 0. What you get? This is 0 pi square by 3 summation 4 minus 1 raised to n divided by n square cos x equal to 0, cos 0 is 1. Okay, pi square by 3 as it is. Expand this series. Okay, expand this series. What you get here? To expand this series, pi square by 3 plus 4 into, put n equal to 1, we get a minus 1 raised to n, plus put n equal to 2, minus 1 square divided by 1 square, minus 1 cube by 3 square, minus 1 cube by 4 square, so on. Okay, solve this, we get a, this pi square by 3 can be taken in LHS part, we get a minus pi square by 3, 4 is a common, minus 1 plus 1 by 2 square minus 1 by 3 square plus 1 by 4, so on up to. These 4 can be taken in LHS. What you get here? We get a, the solution is, we get a, these 4 taken in the, this term we get a 1 minus 1 divided by 2 square plus 1 divided by 3 square minus 1 by 4, so on up to we get a pi square. This 4 taken in the, this term we get a 3 into 4, that we get a 12. So this is the, we get the series. Okay, see here, if they are asking only Fourier series, we'll solve this much only. Okay, if deduce the series in terms of series, any of the they given, put x equal to 0, x equal to 1 or x equal to pi. Okay, it depends on the series. Here they given pi square in the form of series, 1 minus 1 1 by square minus 1 by 3 square plus 1 by 4 square. That's why I'm taking x as a, x term is not there. That's why I'm putting x equal to 0. Okay, so this is the solution of a Fourier series. In next class I will explain.